Okay, when you're done with creating the SST, you should have a SST folder and most importantly, a template 6, which is the actual SST itself. And in addition to this, SPM would have generated some U flow fields. You'll see this over here. So apart from the RC nifty files which you needed from the segment step to do the study specific template, once you run the study specific template, SPM will generate a new U flow field based on the RC1 image. So this is the result of the SST, all right, which is the, if you understand it, it's the deformation information to move from the subject's own space to the SST space, all right, to the template mean template space. But that's not enough. We also have to move the subject's images from the subject space to the template space and then to the MNI space. And moreover, we need estimates for that. We need to do that, and we also need to actually generate EPIs. So we need to move these slice time and corrected EPI images from the subject space to the standard study specific template space, and then to the MNI standard template space. And we can do all of that in one step and with the tool that is here. So again, you open the batch editor. You can ignore all of that. We don't need that anymore. So we're gonna just say we want a new batch. And so to move the EPIs, okay, now that we have the SST, we want to move the EPIs to the SST and then to the MNI space. And to do that, you go to Tools, Dartel Tools, and you just click Normalize to MNI space. It's really very simple. And here, you can read the help again in your own time, but we would have talked about this principle or concept in class, and here I'm just showing you how to do it using SPM. We go to the Dartel template, we specify, we tell SPM where the Dartel template is, the SST, where is it, right? So that SPM can move the EPIs to this SST intermediate step first. And as I said before, it's this template 6. So we select that and put that here, that this is the Dartel template. And then we want to tell SPM where all the EPIs are. And there's two ways that Dartel allows us to do this. One is the few subjects way, and the other is the many subjects way. For now, for the EPIs, I would suggest you use the few subjects way. So you select that. And then go up here to where it says few subjects above. Select that. And you want to you want to select, you want to specify one new subject for every subject you have. We have 6 subjects worth of EPIs. So we're going to click this 6 times. 1, 2, 3, 4, 5, 6. Now note, every subject that you create, it will require you to enter a flow field and then also to specify the images. This is very obvious. If you click the flow field, this is for subject Y01, Y02, Y03, and so on and so forth. And we will need to specify the details for Y01 first. So flow field for Y01, if you click on it and go to Y01, you'll see that it's going to ask you for the flow field, which is the U, the image with the U in front. So as I said before, this is the flow field, which is the deformation information to move from the subject's own space to the SST, which we calculated just now. So go ahead and click this. All right, so this specifies the flow field for subject Y01. And then we want to specify the images that we want to move and some other things. For now, we are going to select ARY01 and ARY02. Note, it's going to do it on the whole 4-dimensional image. There's no frame to select here. So it's very easy. You just click on Run 1 for Y01 and Run 2. And note, we do it on the slice time and motion realigned images. And these, again, are, the T2 and the T1 were all co-registered to this image. So that's why we can apply the SST parameters to these EPIs. So you have to be very clear and very careful that these are co-registered to the T1. And that's it for this one subject. We only want to normalize, move the slice time motion corrected images from the subject space to the template space, and then from template space, it will move it to the MNI template space. From the subject space to the study specific template space, and then to the MNI template space. So we go ahead and click done. And we're done with specifying the stuff for subject Y01, and we want to move ahead for subject Y02. So same thing, go to Y02, select the flow field for Y02 as the in the flow field field, and then for the images, you want to select Y02's slice time and motion corrected images, and click done. And again, all of these, you can go ahead and click it, but I've already done it for my own data set, and what I'll do is I will drag it in again and load my preloaded batch file so that I don't have to click so many things here, which I've named Dartel normalise MNI, normalize to MNI. So you can see that I've selected everything. You'll see that I've selected 3 files here. I've gone ahead and also included the MP range in here, but you don't really need to do this, all right? And also, actually, you shouldn't do this because it's going to apply some smoothing, and I'll talk about that later in a bit. And really, you only want to smooth the EPI images. You don't want to smooth the MP range images. So please ignore this step that I've selected here in my batch file. I've just gone ahead and left it in there anyway because it's not important. It doesn't really make much of a difference. You can leave it in there. It will run it, but you don't really need that step. You only really need the 2 EPI runs. But I just like to be consistent. If you selected it for one subject, you want to go ahead and specify the same for all subjects. So in my batch file here, I have the flow fields for Y01, Y02, all the way to 003, and the corresponding subject images for which I want to move the images or deform the images from subject space to the SST space and then to the MNI space. All right. So once you've set this up, let me explain a little bit more here about the specifications at the bottom. Here it asks you for some voxel size information. Now, this is to tell SPM, like you want to generate normalized images in MNI space from the original EPI in a given resolution. So when you leave it as not a number, nans here, SPM will just use whatever was the resolution of the template and apply it to the resulting images. Sometimes you might want to specify your voxel sizes. For example, you want it to be isovoxel 3 millimeters by 3 by 3, in which case you should type 333 here. All right. Another thing to note is that it does here the Gaussian full width half maximum images, smoothing on the images. So not only will it normalize the images to MNI space, it will also smooth it with an 8mm 3D kernel. And you will see that the output images will have S prefix in front as well as a W prefix in front. W meaning that it has been normalized, and the S meaning that it's been smoothed. If you don't want it to smooth, you can also specify that this Gaussian kernel be 0, as is indicated here. All right, but in this case, we're just going to leave it as such because we will be smoothing our data. Another thing to note here is the preserve option. Remember, as we talked about before when we did segment, when you warp or deform the image, you kind of either shrink or expand the volume or the area, right? And there's two options. Either in SPM, you can either preserve the concentration so that when you shrink a volume, you have to increase the weights of the signal to kind of take into account that the original volume has been shrunken, so the density is preserved. All right, the intensity or the density is preserved. Alternatively, you can do preserve amount, which would preserve the volume, but you will lose the information that that volume came from a bigger or smaller original, volume, um, um, as we talked about in class. All right. So in this case, we're gonna leave it as default to say preserve the concentration, and then we're gonna save this batch, and which I've already done. I'm just gonna save it is normalize MNI.mat, and I will. You can go ahead and save it. I'm not going to overwrite. And once that's done, you can click play. And what will happen is that it'll take a while, but SPM will then, for every subject, generate the corresponding smooth and normalized EPI images, which are the SWAR Y01 files for run 1 and run 2. Really, that's what we want as the end product of all our pre-processing steps. All right, so if you've played this and it's completed, you should see for every subject, you should have a SWAR file. I have it for my Y01. I'm just going to show you another example that I also have it already for my 003 here, if I can find it. Here we are. All right, and so you should have these as your output. And just to kind of show you what it looks like and to convince you that it's been kind of normalized already, I'm going to use checkreg. It's normalized and smooth. I'm going to use checkreg, and I'm going to open the original AR file, EPI file. I'm also going to open the same run file, but with the SW open prefix. Not only that, I'm going to show you that it's done it the same for frame 1, because remember we only selected the 140 file, 40 image file, but it would have applied the same deformation to frame 1 as it would have to frame 150. All right, so I'm going to show that to you for the young subject, and I'll show you the same thing for the older subject. So for the older subject, we're going to select the original subject space image, and then we're going to do the older SWA image, as well as for frame 1, as well as for frame 150. And then we're also, just to drive home the point, I will show you the SST, which we saw just now, and also the TPM. And we should expect that the SW images will match the TPM, and not the SST, and not the subject space images. So this is the original Y01's AR image in AR in Y01 space. You can see that if I click here, this is the SST, the TPM at the bottom here. It's not really aligned. You can tell that this is nice and aligned, kind of oriented in a nice, neat way. But here you can see it's a bit tilted. So this is still in the subject space. But here, this is the smooth and normalized image for subject Y01. And you can see if I click through, it is in MNI space if you match it with the TPM at the bottom. And this is for volume 1 for Y01, and this is for volume 150. You can see here that the two are have the same deformations applied to it. All right. And note here, this is the SST. So the SST is kind of like in the middle. It's not really the TPM, nor is it the subject, right? So this is the mean image for these 6 subjects that we have tried the processing on. And here, just to show you again, it's the same thing. This is the older subject in the native subject space, and then the normalized and smooth older adult subject, which is matching the TPM pretty well. So now we have all these SW smooth and normalized EPI images, which have been slice time corrected and motion corrected and co-registered and everything. We're all good now with the pre-processing, and we'll be ready to move on to the statistical analyses next.